All right, so in this video, we're going to take a look at Newton's method, see how this brilliant man used a method, now it's named after him, to find zeros or to approximate zeros on graphs as it crosses over your x-axis, or to find intersections of graphs as well. So we're going to look at both of those. So first of all, let's look at his method and kind of where it came from, how he created it, how it works, and why it's tied into what we're currently doing in calculus and with slopes and all of that. So first of all, let's take a look at the equation that he used to come up with this. So first of all, we know that if we're finding, let me draw a graph for us here real quick. If we're trying to find a zero, well, right now, what we would probably, most of us would probably just plug into a graph to figure out where that's at, right? But let's set this thing up. So let's say, even when you are having your calculator to find a zero, you have to give it a left and a right point, right? Or some calculators, it's just, hey, get me near it so that I can approximate near this thing, and it's using a method similar to, if not exactly, Newton's method. So let's say that this is your guess right there. Okay, then with this method, what you'll do is you'll run the approximation and boom, it'll give you an answer closer to. So this is your first guess. This is your second. This is your first. And then you run the approximation. This would be your second. And then it'll give you an x sub 3. That would be like your third. And you notice if you keep running this approximation that we're going to learn, it'll get you closer and closer and closer to the actual answer itself. So how this thing works is it works off the idea of slopes, right? So it uses, like right here, this is our first guess. That's the point on the line of our first guess. So that's going to be x sub 1 and f of x sub 1. Okay, so they're using the slopes of that first graph, or the change in slopes, to get a better approximation. Right, so we know that the equation for a slope is y minus y, but in this case, f of x sub 1 is equal to our slope, but now in calculus, our slope looks like this, f prime at that point of x sub 1, and then times the quantity of x minus x sub 1. All right, so this is an old school y minus y is equal to m times x minus x. It's just written differently to apply to this specific scenario. All right, so now if we were to find the, and what we're trying to do is find the x-intercept, think about what you would do here in this particular equation. Well, in any equation, how do you find the x-intercept? Right? That is where y is equal to 0. So go ahead and plug 0 in for your y function right here. Try that and then come back. Pause the video, try it, and then come back and see how you did. It's not in there. It's you don't plug it in for your known, right? You would actually plug it in right there, right? Because we know x sub 1 is not, or f of x sub 1 is not 0. So you're plugging in for that y there. Okay, so when you plug 0 in, it's 0 minus f of x sub 1. So that 0, you can just ignore it. And now our goal, again, is to figure out where it crosses over. And so our goal is to figure out what that x value is. So this right here, that is our x value that we're looking for. So we need to get this thing by itself. So the first thing we're going to do is divide out the f prime. So you're going to divide out the f prime of x sub 1. Gets rid of it there. And then you would have on this side just x minus x sub 1. And so we're going to add an x sub 1 to both sides. Okay, so then you would have x sub 1 minus f of x sub 1 divided by f prime of x sub 1 is equal to your x. And what that actually does for us is that gives us our first, or actually our second guess. That would give us our second guess. So that becomes, in my little picture at the left, x sub 2. Okay? And then once you know all of these values, because you are choosing an x sub 1, so you know what that is. You're saying that's close to the 0, but I don't exactly know what the 0 is. Then you plug x sub 1 into your function to find that. Find the derivative of your function and plug your x value in to find that. And then that gives you a better guess. And then you would plug that back in to your equation. And so it's just a reiteration, right? So then x sub 3, so I'm just going to, don't write this in your notes, but x sub 3 would be everything you see up here, but with x sub 2. Okay, so you can see how it just iterates over and over until it gets closer and closer, until it gets to that point, or really, really close to that point. A quick example here. 2 iterations of Newton's method approximate to 0, and our x sub 1, the 0 is going to be around 1.4. That's our initial guess. All right, so we know that our f of x is x to the third minus 3. Our derivative is just going to be 3x squared minus 0, 3x squared. And then our x sub 1 that we're starting at, they give us that starting value. So the 0 is around x equals 1.4. It's not equal to 1.4, but it's close. So now what we're going to do is we're going to figure out what our x sub 2 is by running our first iteration, right? So it's going to be x sub 1. I'm going to write this out and then I'll just fill them in. But it's x sub 1 minus f of x sub 1 all over the derivative of that. Okay, but I'm going to fill these in with my knowns because now my x sub 1 is 1.4. Minus, I'm going to plug 1.4 into my function. So f of 1.4, so you could do 1.4 to the third minus 3 all over 3 times 1.4 squared. You punch this into your calculator and you'll end up getting 1.4 minus, on top, it's a negative 0.256 over 5.88, which gives you 1.44354. 1.44354. Okay, so right here, this is our x sub 2. Okay, that's a close guess. That's one iteration. Let's do it again. So now we want our second guess, or actually our third guess, right? We want our third guess using x sub 2. So instead of 1.4, I'm going to use 1.44354. Always go out at least 4 decimal places to the right. I went out 5, but at least a minimum of 4 decimal places to the right of your decimal. So it's going to be that minus 1.44354 to the third minus 3 all over 3 times 1.44354 squared. And then that'll give us that approximation. When you plug it in, it's going to be 1.4423, right? That is our x sub 3. Third guess. And if you look at a calculator, you'll see if you find the 0, again, you have to give the calculator an approximation so it knows where to start, just like you have to do with Newton's method. But you'll see that it's going to be really, really close to that, 1.4423. All right, so that's the end of this video. The next video, we'll do 2 more examples that are a little bit more in depth. So make sure you watch that one.